Section 3.2, Symplectic division. Remember long division? We want to use the long division to evaluate this polynomial. But before that, I want you guys to remember like all those terms for the long division. For example, if I want to find out 75 divided by 4, okay? So we're gonna use the long division, 75 divided by 4. So we're gonna look at the 7 only. So 4 times 1 equal to 4. And that's a little subtraction here, right, for the division. So 7 minus 4, we're gonna get the 3 here. And then we're gonna bring down the 5. So, and then 4 times x equal to 32. And then we're gonna subtract it one more time. So that will be equal to 3. Okay, so I need you guys to remember this term. The 75, this number, okay, 75. We call this is gonna be the dividend. And then the 18 here, we call this is gonna be the quotient. Okay, and then this 4 here, which is the 4 here, we call this is gonna be the divisor. And then last one, we call the 3 here, we call this is gonna be remainder. Okay, right? So if I write it out, I could say 75 over 4. Divided by 4 means over 4. That would be equal to the quotient 18 plus the remainder 3 over the quotient here. Okay, so you always can check your work. If you're not sure if you get the correct answer, you could get the same denominator times 4 here times 4 here, and then add it up. It's supposed to be equal to 75. Okay? So how about this one? We have the polynomial. So let's try together. Okay, let's do together. First, we have the dividend inside 3x cubed minus 2x squared. This is the polynomial. So 3, 2, we skip the 1 here. So what we're gonna do, we're gonna put 0x. Okay, make sure you do have a descending order here. 3, 2, 1, 0. And then we have a minus 150. And then we have a x minus 4. So we're gonna look at these two terms. We're gonna look at 3x cubed and then x. What can I write it here? I could put 3x cubed divided by x. So you subtract it, 3 minus 1, the exponent, I only have a 3x squared. Okay, so I'm gonna put 3x squared here. I'm gonna multiply by 3x squared times x. So it has to be equal to the third term here. And then multiply the second one, 3x squared times negative 4. So I have 12x squared. Okay, make sure the exponents, they do have the same degree here. Okay, x cubed, x cubed, x squared, x squared. And then we know this is a division, we do have the subtraction here. So 3x cubed minus 3x cubed, that's equal to 0. So this is good. And then this one, negative 2x squared minus negative 12x squared. So that will become negative, negative, become positive. So add it up, you should have 10x squared. And then we're gonna bring down the 0x here. Okay, this time, I'm gonna look at the first term. We do have a 10x squared. We're gonna divide it by x, which is gonna be 10x. So now I'm gonna multiply by plus 10x. Do it one more time. 10x times x, I have a 10x squared. And then 10x times negative 4. So I have a negative 40x. Okay, another subtraction here, get a 0, and this one, negative become positive. So 40x, and then bring down the negative 150. Okay, last one, 40x divided by x. I know I'm gonna be multiplied by 40 only. Okay, 40 times x, I'm gonna get 40x. And then minus 40 times 4, 160. Okay, and other minus sign here. So I have negative 150 plus 160, which is gonna be 10. So this guy gonna be my remainder. Okay, I'm gonna circle it. This one, that will be the remainder. And then one more time, I have this guy, that will be my quotient. And then x minus 4, that will be my divisor. Okay, last one. This one, that will be my dividend. Okay, right? And then, so I want you guys write down the final answer. That will be the dividend divided by divisor equal to the quotient plus the remainder over the divisor. This is how we write on the final answer. Okay, so I'm gonna plug it in. My dividend will be 3x cubed minus 2x squared minus 150 divided by the divisor x minus 4, which is gonna be equal to the quotient 3x squared plus 10x plus 40, and then plus the remainder divided by the divisor. So this is gonna be my final answer. Okay, double check. Okay, let's see. My solution's gonna be here. Okay, make sure you add the 0x because we have to write it in order, 3, 2, 1, 0. Okay, and then they're gonna get the same answer as ours. Okay, remainder equal to 10. Write it like this form. Dividend divided by the divisor equal to the quotient plus the remainder over the divisor. Okay, right? This is the long division. We learned it from the algebra. Now, they're gonna rewrite it. Let fx and the gx be the polynomials with the gx of lesser degree than the f of x and gx of the degree 1 or more. Okay, so they write it like they're gonna let this guy, your dividend, become your fx. Okay, and then this is the quotient, so we have the qx here. And then the gx, that will be your divisor. And then rx, that will be the remainder. Okay, so this is how they write on here. So I'm gonna keep 3x cubed minus 2x squared minus 150 equal to, if they multiply by x minus 4 for the whole equation, so they still have the x minus 4 here, times 3x squared plus 10x plus 40. And then times x minus 4, you cancel out. They only have the 10. So you will have this guy. This is gonna be my f of x. Okay? And then x minus 4, that will be your gx, which is going to be your divisor. And this going to be your answer. That will be your qx. Okay, the quotient, the qx. And then last one, the 10 here, that will be your rx, which is going to be the remainder. Okay, it is exactly the same thing from these questions. Okay, they just multiply by x minus 4 for the whole equation. Okay, now we're gonna teach, there's a new method called synthetic division. Synthetic division provides an efficiency process for dividing a polynomial by binomial of the form x minus k. Okay, if you want to use the synthetic division, your divisor has to be the form x minus k, just like this one. The divisor is going to be x minus k, which is going to be x minus 4. So let's do the same questions here. And I want you guys compare the result, okay? Okay, so this is the method using long division. And now we want to use the synthetic division. We're on the same problem. So I have 3. So I have a 3x cubed minus 2x squared plus 0x minus 150 over x minus 4. Okay, remember that when we're working on the synthetic division, it has to be divided by the divisor x minus k. Okay, so what we're gonna do? First, we're gonna just write down the coefficients here. So I have a 3, negative 2, 0, negative 150. Okay, 3, negative 2, 0, and negative 150. And then I'm going to put the k here. Your k in this form, that will be equal to 4. Okay, so first, we're going to bring down the 3. And then we multiply 4 times 3, we're going to get the 12. For the synthetic division, you could imagine that's a plus sign here. Okay, so add it up together, you're going to get 10. And then multiply 4 times 10, you're going to get 40. Add it up together, 40. And then 4 times 40, which is going to be 160. Add it up, you're going to get the 10. Okay, so this 10 here, that will be your remainder. Same idea, this is going to be my remainder. And then the k here, x minus k, which is going to be your 4, which is going to be your divisor. How about the quotient? Quotient is talking about this 3 guy. Since you already know, for our dividend, we're starting from x cubed here. X cubed, x squared, x, and then the constant. Right? Whatever you get the quotient, you're gonna subtract from 1. If this is x cubed, this guy become 3x squared. Okay, the quotient that will become 3x squared plus 10x plus 40. Okay, if this is x fourth, then you will have an x cubed here. If this is an x7, then this is gonna be x6. Okay, you always subtract 1 degree from the dividend. Okay, but actually this is a lot easier compared with the long division. You're gonna get the same answer, right? 3x squared plus 10x plus 40. This is how you get the quotient. We do have a remainder 10 here. Okay, so at the end, write down the answer, just like this guy. Okay, right? This is called synthetic division. Okay, so one more time, we're gonna write down the coefficient of your dividend. Bring it down to 3 here, multiply. 4 times 3, you gotta get a 12. Add it up, 10. 4 times 10, 40. Add it up, 40. Times it, 160. Add it up, you're gonna get the 10. That will be your remainder. Okay, so this is exactly the same thing. 3x squared plus 10x plus 40 plus 10, the remainder, divided by the divisor, x minus 4. Okay. That's it. So these sessions, I need you guys to know how to use the synthetic division to divide up the polynomial. Okay, but keep in mind, when you use the synthetic division, your divisor has to be the binomial form, only 2 terms, and the form will be x minus k, okay? Okay, try this one. Use the symphatic division. Okay, I started a little bit. So I'm gonna put it down 4, -15, 11, and -10. And this is x minus k. So your k is gonna be equal to 3. So first, you're gonna bring down the 4. Okay, I want you guys to try use the symphatic division to divide this polynomial. Once you're done, I need you guys write out the form like this one. Okay, write it out like this for your final answer. Okay, so multiply it, gonna get a 12, add it up, -3. So 3 times -3, -9, add it up, 2. Multiply it, 6, and that will be -4. That will be your remainder. So write it down for your final answer. Copy the questions and then equal to the quotient. Since this is an x cubed, okay, so you subtract 1 degree. So this guy becomes 4x squared minus 3x plus 2. Okay, and then remainder -4. So -4 divided by x minus 3 here. For any polynomial f of x and any complex number k, there exists a unique polynomial qx and the number r such that the following holds. We just experienced this one. Remember that f of x equal to gx. Your gx become x minus k here. And then times the qx plus the rx, the remainder. Okay. For example, we just use the previous example here. Okay. We multiply x minus 3 for the whole equations. So this is gonna be your function x. And this is x minus k. And this is gonna be your quotient. And -4, that will be your remainder here. So why we want to write it like this form? Because we want to use this form to developing the remainder theorem. What is the remainder theorem? If the polynomial of fx is divided by x minus k, the remainder is equal to f of k. So let's look at this previous example. We know that when we have the f of x divided by x minus 3, then you're gonna get the remainder -4. Right? This is, we just covered the example from the here. Right? Divided by x minus 3, we're gonna get the remainder -4. So by the remainder theorem, when you plug in f of k, you're gonna find out the remainder as well. So let's try. We already know the remainder of this guy will be equal to -4. Let's try to plug it in. F of 3, plug it in here. And then you're gonna calculate. Use your calculator. You should find that will be equal to -4. Okay, so this is the remainder theorem. So we got f of 3 equal to -4. It matched to our solution here. When we use the symphatic division, plug in x equal to 3, we find it out the remainder is equal to -4. Same idea when you plug in strictly to the function of x. Okay, this is called remainder theorem. So now let's try to applying the remainder theorem. First, I want you guys try to use the symphatic division. Okay, plug in k equal to 4 here. Try. Okay, bring it down, multiply it, and then add it up, you're gonna get the 3, right? 3 times 4, you're gonna get a 12. Add it up, 12 times 4, you got 48, -2, okay? So you should get the remainder is gonna be 17. So by the remainder theorem, if we plug in x equal to 4 here, okay, plug in x equal to 4 into this function, we should got the same answer. That should be equal to 17. Okay, so this is gonna be the remainder theorem. Testing potential zeros. A zero of a polynomial function f of x is a number k such that f of k equal to 0. The real number zeros are the x-intercept of the graph of the function. So this is talking about when you want to find the x-intercept, you're gonna plug in y equal to 0. That means f of x equal to 0. If you could find a number of k and plug in the f of x, and then you got the answer equal to 0, then k will be your x-intercept. Okay, this is the idea. Remainder theorem help us to finding the potential zero, and the zero is talking about the roots or a solution. Let me give you guys a simple example. For example, I have f of x equal to x squared minus x minus 6. Let's say I plug it in f of 3. Okay, so I plug in here 3 squared minus 3 minus 6. So that will be 9 minus 3 minus 6, which is gonna be equal to 0. So by the remainder theorem, f of 3 equal to 0, then 3 will be my x-intercept. Will be equal to 3. And then I could plug in one more point, let's say f of 1. So 1 squared minus 1 minus 6, which is going to be negative 6. This is not equal to 0. So I know x equal to 1. This is not a zero of function x. And then let's say plug in negative 2 here. Negative 2 squared minus negative 2 minus 6. So I'm going to get 4 plus 2 minus 6, which is going to be equal to 0. So another intercept, that will be negative 2. When we have this function, x squared minus x minus 6, if we could find the zeros, x equal to 3 and x equal to negative 2, when you plug into this polynomial, you're going to get 0. So I could write it down, f of x, that will be equal to x minus 3 and x plus 2. Okay, only look at here. And then we say, if this is equal to 0, then we could find out x equal to 3 or x equal to negative 2. I need you guys remember the terms. A zero of f of x, that's called a root or solution. This is talking about these two guys. You could call this is the roots, or you can call this is gonna be the solution of the function x. Okay, so the remainder theorem gives us an idea. How can you find out the zero for the polynomial of functions? You could just plug in to the point, to the function x here. If this is equal to 0, that will be your x-intercept. And also, these 2 points will be the root, or this is called solution of the f of x. Okay, let's try this one. We have the f of x, and I want to know is k equal to 2 a 0. So let's plug it in, find out f of 2. Or you could use the symphatic division. Okay, plug in k equal to 2. So try. You should get the remainder is gonna be negative 14, right? So you know k equal to 2 is not a 0. For this kind of the questions, you could use the symphatic division. Or you can plug in x equal to 2 for the whole equation. You calculate it, you should get equal to negative 14 as well. Either way, okay? Okay, try this one. Use the symphatic division. Try your work. Oh, that's equal to 0. So f of negative 3 equal to 0. So negative 3 is a 0, or is a solution of this function x. Okay, last one. This time, we do have a complex number. We're gonna do the same thing. Okay, bring it down to 1 and then multiply it. Add it up. So combine the like terms, it's only 3i here. So 3i times this guy. You're gonna get 3i plus 9i squared. Remember, what does I squared equal to? I squared is gonna be negative 1. So that's why we have this one. Add it up and then multiply it again. So you get k equal to 1 plus 3i. The remainder will be equal to 0. So 1 plus 3i is a 0. Okay, it's a solution of this function x. That's it.